Hello students, in the previous class we had solved few problems based on the type 4, that is infinity to the power of 0 and 0 to the power of infinity, 0 to the power of 0 form. Let us solve few more problems here. Next your problem is limit x tends to pi by 2 secant x whole to the power of cot x. So here observe here, so we don't know which form it is. Either it can be 0 to the power of 0 or infinity to the power of 0 or 1 to the power of infinity. First we have to confirm among these three indeterminate form which type of indeterminate form it is. So first what you have to do, substitute the limit in the given function. Here secant x is f of x and cot x is g of x. So secant x value is pi by 2 whole to the power of cot pi by 2. So secant pi by 2 is infinity, cot pi by 2 value is 0. So the given function is in the form of infinity to the power of 0. So limit x tends to pi by 2 secant x whole to the power of cot x is in the form of infinity to the power of 0 form. So after confirming that this is infinity to the power of 0 form, first what you have to do, then you have to equate the given term to L. L equals limit x tends to pi by 2 secant x whole to the power of cot x. So secant x whole to the power of cot x. Then taking log on both sides. Taking log on both sides. Log L equals limit x tends to pi by 2 as it is. So as you have the power cot x as power here to secant x, so what happens when you apply log to this term, cot x into log secant x. So log of secant x. So after differentiating so after applying log, you will get as log L equals limit x tends to pi by 2 cot x into log secant x. Now we have to confirm which type of form it is, whether it is 0, you see here it cannot be 0 to the power 0 or infinity to the power of 0 or 1 to the power of infinity. It cannot be that form. So it can be either it can be 0 into infinity form or infinity minus infinity. So by seeing itself we can say that this is a 0 into infinity form. So cot pi by 2 log secant pi by 2. So log cot pi by 2 is 0 into here what is log secant pi by 2 secant, so it is infinity. So the given function is in the form of 0 into infinity form. So here when you have 0 into infinity form, either you have to convert it into infinity by infinity form or 0 by 0 form. So equated log L equals limit x tends to pi by 2. Since here log secant x cannot be brought to the denominator, instead log this term you can cot x can be brought to the denominator. So log secant x as in the as it is in the numerator divided by cot x can be written as 1 divided by cot x. So cot x written as 1 divided by cot x. So here then log L equals limit x tends to pi by 2 log secant x, 1 divided by cot x can be written as tan x. So tan x, see observe after again you have f of x by g of x form here. So it is f of x, this is your f of x and it is in the g of x form. So we don't know whether which form it is, either it can be 0 by 0 form or infinity by infinity form. So first we have to confirm which form it is. So log secant x is log secant pi by 2 divided by tan pi by 2. So it is in the form of infinity by infinity form. So the obtained function is infinity by infinity form. Next, when you have infinity by infinity form, you can differentiate the numerator and denominator separately. So limit x tends to pi by 2 differentiation of log secant x is 1 divided by secant x. Secant x differentiation is secant x into tan x. So what is the tan x differentiation? Secant square x. So this secant x get cancels. Tan x limit x tends to pi by 2 tan x divided by secant square x. Here the tan x can be written as sin x by cos x. So here sin x divided by cos x. So 1 by secant square x can be written as this, 1 divided by secant square x can be written as cos square x. So here this cos x and this cos x gets cancels. Limit x tends to pi by 2. Here sin x into cos x, sin x into cos x. So here when you apply for this limit, sin pi by 2 is 1, cos pi by 2 is 0. 1 into 0 is 0. Here you have log L. So when you shift log to this term, it becomes L equals e to the power of 0. E to the power of 0 is 1. So the value of 1, L is 1. What is the L value of L is? Hence we have equated L to limit x tends to pi by 2 secant x whole to the power of cot x. So hence limit x tends to pi by 2 secant x whole to the power of cot x value is 1. Next, let us solve one more problem. Next, the problem is limit x tends to 0, 1 plus sin x whole to the power of cot x. So 1 plus sin x whole to the power of cot x you have. So we have to confirm which type of indeterminate form it is. So it is like this is your f of x and this is your g of x. So f of x and g of x you have. So 1 plus sin 0 whole to the power of cot 0. 1 plus sin 0 is 1, sin 0 is 0, 1 plus 0 is 1, cot 0 is infinity. So it is in the form of 1 to the power of infinity form. Solution, let's write the given problem. Limit x tends to 0, 1 plus sin x whole to the power of cot x. So the given function is in the form of 1 to the power of infinity form. 1 to the power of infinity form. Next, after confirming the indeterminate form, you have to equate the given term to L. So L equals limit x tends to 0, 1 plus sin x whole to the power of cot x. After equating the term to L, you have to take log on both sides. So taking log on both sides. When you take log on both sides, it's become log L equals limit x tends to 0 as it is. Since you have cot x as power here, cot x into log 1 plus sin x. So here, then this is cot x. So limit x tends to 0. So it is, by seeing itself, you can say that the given function is in the form of 0 into infinity. So cot x, 0 is infinity, infinity into 0 form. So either you have 0 into infinity form or infinity into 0 form. You can convert it into either infinity by infinity form or 0 by 0 form. For our convenience, we will write log of 1 plus sin x as it is in the numerator, and this cot x can be written as 1 divided by cot x. So 1 divided by cot x. So 1 divided by cot x is, can be written as tan x, log of 1 plus sin x divided by tan x. Even see here, log of 1 plus sin x as it is, 1 divided by cot x can be written as tan x. So we have to confirm which type of form it is. Infinity into 0 form should be converted into either infinity by infinity form or 0 by 0 form. So we'll confirm. See here, log of 1 plus sin 0 divided by tan 0. So log of log 1 divided by 0. Log 1 is 0. 0 by 0 form. So this is 0 by 0 form. The given function has converted to 0 by 0 form. So when you get, after getting 0 by 0 form, you can differentiate the numerator and denominator separately. Limit x tends to 0 as it is. Log of 1 plus sin x is 1 by 1 plus sin x. Sin x differentiation is cos x divided by tan x differentiation is secant square x. So here limit x tends to as 0 as it is. Here you have log L. So secant square x can be written as cos square x into cos x divided by 1 plus sin x. So here what do you have in the numerator? Limit x tends to 0. Limit x tends to 0. Cos square into cos x is cos cube x divided by 1 plus sin x. So limit x tends to 0. When you apply limit for this, cos 0 is 1 divided by 1. 1 plus sin 0. Sin 0 is 0. 1 divided by 1 is 1. So log L equals 1. So when you shift L to that side, it becomes L equals e to the power of 1. So what do you have? L value as L equals e. Hence, what we have equated L to? Hence, L is equals to limit x tends to 0, limit x tends to 0, 1 plus sine x whole to the power of cot x equals e. Hence, the value is e. Now we have solved 1 to the power of infinity form. So let us solve one more problem based on this type 4. Then one more problem is limit x tends to 0, cosecant x whole to the power of 1 divided by log x. So here let us confirm which type of indeterminate form it is. So here cosecant x, so cosecant x is nothing but cosecant 0 whole to the power of 1 divided by log 0. So here cosecant 0 is infinity, log 1 divided by log 0 is log 0 is 1 by log 0 is infinity. So here infinity, 1 by infinity is 0. This equals infinity to the power of 0 form. Hence let us write limit x tends to 0, cosecant x whole to the power of 1 divided by log x is in the form of infinity to the power of 0 form. Then we have to equate the given term to L. Limit x tends to 0, cosecant x whole to the power of 1 divided by log x. Then after equating, you have to take log on both sides. You have to equate this whole term to L. After equating to L, you have to take log on both sides. Log L equals limit x tends to 0. So 1 divided by log x, power gets shifted when you apply log. So it becomes log of cosecant x. So here, see, observe here problem, it is in the form of f of x by g of x form. So f of x by g of x form directly. So we can either it will be of infinity by infinity form or 0 by 0 form. Let's confirm which type of form it is. So this is log cosecant 0 divided by log 0. Log cosecant 0 is infinity. So log cosecant 0 is 0. So log 0 is infinity. Infinity by infinity form. The given function is in the form of infinity by infinity form. So when you have infinity by infinity, you can separate the numerator and denominator separately. So log L equals, the given function is in the form of infinity by infinity. Log of cosecant x divided by log x, which is in the form of infinity by infinity form. Then so when you have infinity by infinity form, you can differentiate numerator and denominator separately. So log L as it is, limit x tends to 0. Log x differentiation is 1 divided by cosecant x. Cosecant differentiation is minus cosecant x into cot x divided by log x differentiation is 1 by x. This cosecant x gets cancelled. This is equals to limit x tends to 0, x, when 1 divided by 1 by x you have, so it gets shifted to numerator. You have minus x cot x. So here, here you have limit x tends to 0 minus x into cot x. So limit x tends to 0. So here minus x cot x can be written as 1 divided by tan x. So here, see here, observe this. This term can be written as limit x tends to 0 minus 1 into limit x tends to 0 x divided by tan x. As you all know that since limit x tends to 0 minus x by tan x value is what? It's 1. So this term can be equated to what? 1. So what you have? Limit x tends to 0. So here you have limit x tends to 0 minus 1 into 1. So what is your value? X equals to 1. So sorry, it's minus 1. Limit x tends to 0, minus 1 into 1 is minus 1. So your value is 1. Here what do you have? Log L. So log L you have. So here what do you have? Log L. So here you have limit x tends to 0, minus 1. Limit x tends to 0, x divided by tan x can be written as 1. So limit x tends to 0, minus 1 into 1 is minus 1. So your answer is 1. When you shift log to this side, it becomes L equals e to the power of minus 1. E to the power of minus 1 can be written as L. What do you have equated L to? L is equated as limit x tends to 0 cosecant x whole to the power of 1 divided by log x. So your value is hence limit x tends to 0 cosecant x whole to the power of 1 divided by log x equals 1 by e. Hence the proof.